Meet Hypholoma fasciculare, commonly known as the sulphur tuft, a bright and unmistakable woodland mushroom from the Strophareaceae family. This species typically grows in dense clusters on decaying stumps, fallen logs, and buried wood, often carpeting dead hardwood and conifer remains with vivid yellow fruiting bodies. Recognizable by its sulphur yellow cap, darker orange-brown center, greenish-gray gills as it matures, and bitter taste, it is one of the most commonly encountered wood-decaying fungi in forests across Europe and beyond. Hypholoma fasciculare is considered poisonous and not edible. It should be avoided as a food mushroom under all circumstances. Consumption can lead to gastrointestinal poisoning, with symptoms typically including nausea, vomiting, stomach cramps, and diarrhea, sometimes lasting for several hours. Although not usually considered deadly, it can cause significant discomfort and is responsible for many accidental poisonings due to its abundance and resemblance to other clustered mushrooms that grow on wood. This makes careful identification especially important for anyone collecting wild fungi. It has no culinary tradition and is not regarded as suitable for consumption at any stage of development. The flesh is thin and relatively tough, with a strongly bitter taste. Its smell is usually mild but can be slightly earthy or musty, often with sour or woody notes, reflecting the decaying timber from which it grows. Some people describe the odor as damp wood mixed with leaf litter, without anything particularly pleasant or appetizing. For that reason, Hypholoma fasciculare is valued as a species to observe and identify in the forest rather than as a mushroom for the kitchen. Hypholoma fasciculare is a wood-inhabiting mushroom that almost always appears in dense tightly packed clusters rather than as solitary fruit bodies. These clusters often emerge from the same point of a decaying stump or buried root system, giving the impression of a single interconnected growth spreading across the substrate. The caps are small and relatively uniform in size, typically 2 to 5 centimeters across, and shift in shape as they develop. Young specimens are more rounded and compact, while mature caps become flatter with slightly uneven and sometimes uplifted margins. Their coloration is distinctly two-toned, with a brighter yellow outer zone contrasting a darker orange-brown center that tends to remain visible even in older specimens. Gills are an important structural feature, beginning in a pale yellow phase and progressively darkening as the spores mature. This transition often creates a layered effect within the cluster, where different stages of development are visible at the same time. The final gill color typically moves toward olive green or grayish-brown tones, which is useful for separation from similar yellow fungi. Stems are slender, fibrous, and often slightly curved due to the crowded growth pattern. They frequently originate in bundled groups sharing a common base where multiple fruit bodies emerge together. The flesh inside the stem is thin and lacks any notable internal structures, breaking easily without producing latex or discoloration. From a sensory standpoint, the species is characterized by a persistent bitterness that becomes apparent even in small samples. The smell is subtle rather than strong, usually presenting as a mild mix of damp wood and forest floor debris, without any sweet or fruity notes that are sometimes found in edible species. Overall identification relies on observing the clustered growth habit, yellow to green color progression in the gills, bitter taste, and strict association with decaying wood, all of which together separate it from other similar-looking forest species. Hypholoma fasciculare is primarily a saprotrophic species, meaning it develops on and feeds from dead or decaying wood. It shows a strong preference for hardwood stumps, fallen trunks, and buried root systems, where it can extract nutrients from decomposing organic matter. It is most often encountered in damp shaded forest environments where moisture levels remain high enough to sustain wood decay. These conditions are commonly found in mixed and broadleaf forests, although it can also occur in coniferous woodland wherever suitable dying wood is available. Seasonally, it tends to fruit in cooler and wetter periods, especially after sustained rainfall. During these times, it can appear very suddenly and in large numbers, with fruiting bodies emerging almost simultaneously across a single log or stump system. Rather than being restricted by tree species, its distribution is determined by the availability and stage of wood decomposition. It typically favors wood that is already well broken down, where fungal competition is reduced and the substrate is soft enough for rapid colonization. On a broader scale, Hypholoma fasciculare is widely distributed across temperate regions of the northern hemisphere and is frequently observed in both natural forests and managed woodland areas, wherever decaying wood is left undisturbed long enough to support fungal succession. Hypholoma fasciculare develops under cool to mild temperature ranges, typically fruiting during late summer, autumn, and often continuing into early winter in regions with stable humidity. It is strongly influenced by moisture availability rather than strict seasonal timing, with fruiting triggered after periods of sustained rainfall that rehydrate decaying wood substrates. Optimal growth conditions occur in environments where temperatures remain moderate, generally between approximately 10 degrees Celsius and 20 degrees Celsius. Within this range, decomposition processes in wood are active enough to support rapid mycelial expansion and subsequent fruit body formation. Humidity plays a central role in its development. The species prefers consistently damp microhabitats, where fallen logs and stumps retain moisture beneath bark layers or within shaded forest floors. In drier periods, fruiting is significantly reduced or delayed, even if suitable wood is present. Light exposure is not a primary limiting factor, but it tends to favor shaded or semi-shaded positions where moisture loss is minimized. Dense forest cover or sheltered woodland interiors provide the most stable conditions for repeated fruiting cycles. Once environmental conditions become favorable, fruit bodies can appear rapidly and in large numbers, but they are equally transient. As substrates dry out or temperature conditions shift, fruiting ceases quickly, with the species retreating back into its wood-based mycelial network until the next suitable moisture cycle occurs. Hypholoma fasciculare functions as an efficient wood-decaying saprotroph, specializing in the breakdown of lignin and cellulose within dead tree material. By actively decomposing stumps, fallen logs, and buried roots, it converts complex woody structures into simpler organic compounds, gradually returning carbon and nutrients back into the forest soil. Within the decomposition sequence, it often appears in mid to later stages of wood decay, where it contributes to the structural breakdown of the substrate and accelerates its integration into the forest floor. In doing so, it helps create microhabitats for other fungi, bacteria, and invertebrates that depend on softened, nutrient-rich wood material. It also plays a role in shaping fungal community dynamics by competing for space and resources on the same substrates. Its rapid colonization and dense clustering can limit the establishment of slower-growing species, making it a strong competitor within the decomposer ecosystem. Ultimately, Hypholoma fasciculare is an important component of nutrient cycling in woodland environments, acting as both a recycler of dead organic matter and a key participant in the continuous renewal of forest ecosystems. And that's all about Hypholoma fasciculare, the sulphur tuft, a striking but deceptive presence of the woodland floor. From its bright clustered caps to its hidden role deep within decaying wood, it's a species that reminds us not everything that stands out in the forest is meant to be picked. If you enjoyed this closer look into one of the forest's most common but often misunderstood fungi, consider liking and subscribing for more mycology content. There's always another species waiting just beneath the bark, and another story unfolding in the quiet process of renewal. Until the next one, keep exploring, stay curious, and see you in the next video.